one of your notes packet should be open. You might want a calculator today. If you don't have one, grab one. Today, we are writing equations for circles. Can you put the laptops away, please? Yes, I am actually serious. I want laptops away. So, today we're writing equations for circles, because circles can be on coordinate grids. They don't make functions, so their equations look a lot different than equations you've seen in the past, like y equals mx plus b for lines, or y equals x squared for parabolas. Circle equations look very different. A circle's equation is originally based off of its definition. The definition of a circle is the set of all points the same distance from a given point. It's essentially saying, I'll just use this circle for an example, that this distance is the same as this one, is the same as this one, and 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 this one, etc. I could keep going. Now, being the same distance from that point means that the equation for a circle formula actually is going to look like a modified version of a formula we've already dealt with. Because in order to find, say, this distance, what I would typically do is make a right triangle. And how are the side lengths of a right triangle connected? What theorem? Pythagorean theorem. So, it's a modified version of a squared plus b squared equals c squared, but it's a little more complicated than that. It does have something squared plus something squared equals something squared. Those somethings are x minus h and y minus k, where the center of the circle is at the coordinate point hk. Now be careful with that. The formula has minuses on there, indicating that if the center was at, say, 1, 3, in the equation it would be x minus 1 and y minus 3. So the number here and the number here are opposites. If this is positive, this is negative. If this is negative, this is positive. Equal to r squared. Because if I had that right triangle there, the hypotenuse would always be the radius. So, we're going to write some equations for circles. How we write these equations is going to vary a little bit from the situations. This first set on this front side generally is fairly straightforward. You want to write an equation for a circle, you got to be able to identify its center and its radius. Can you tell where the center of this circle is? The center is at the point where if you were to draw the lines going across the furthest distance, it'd be at their intersection point. What is that coordinate point called? 0, 0. AKA the origin. So I got the center. I also need the radius. Radius is distance from center to edge. Now if I go at an angle, that's hard to find. But if I go horizontal or vertical, I should be able to count it. Distance from here to here? Not 2. 3. The 2 is telling you that each of these lines is counting by 1. 1, 2. That distance across is 3. So, my equation, since the center's at 0, 0, would go x minus 0, quantity squared, plus y minus 0 quantity squared equal to 3 squared. Now, we do simplify these a little bit if possible, but there's going to be minimal simplification. We simplify this if we can. Can we simplify x minus 0? What's anything minus 0? Just the thing. 5 minus 0 is 5. 10 minus 0 is 10. 8 minus 0 is 8. 100 minus 0 is 100. X minus 0 is?
Oh, it's 0 minus the number.
Yes, 0 minus the number is
So
negative.
Okay, I'm just confused.
You just had it backwards. So that's x squared. Plus, can I simplify y minus 0 squared?
Y squared.
It's y squared. Can I simplify 3 squared?
Yeah,
9.
9.
Ta-da.
That's it.
Equation.
That's not solved.
That's all it asks for is to write the equation. Okay. Sometimes they'll give you the center and the radius.
Well, yeah.
We didn't have to discover them. They're given to us. You just plug them in. X minus 0. Close that squared. What goes in between the parentheses?
Plus.
Plus. Y minus
0.
0 squared equals 11 in the square root getting squared. Simplify what we can. Can I simplify this? Yeah, it's just x squared. Don't lose your squareds. Y squared. 11. Ta-da. Okay. This one's centered at negative 2, 5 with a radius of 6. X
-2.
minus negative 2. Close that squared. Plus y
-1. Oh, -5.
minus 5 squared equals 6 squared. Simplify what we can. Can I simplify x minus a negative 2 squared? X plus 2 squared. Can I simplify y minus 5 squared?
Let's do what you did on the other one. No. Oh, I can't.
Do what? What did I do on the other one?
I don't know. You just something like +2.
Minus negative. It's positive.
Oh, we don't have minus negatives, so we can't.
You're right. That one's not minus negative, so we can't. Can we simplify 6 squared?
Yeah, 36.
Now, when you're given the graphs, you got to be careful. Now, when I look furthest across, would you agree that the center is right here?
Yeah.
When talking about coordinate points, do I do up, down first, or do I do left, right first?
Up, down, left, right. Left, right, up, down.
Left and right is the x values, up and down is the y values. So I got to go left, right first. Now I notice that it is 1, 2 bars over, but that's not 2. It's not negative 2. Negative goes in the left direction. It's not 0. It's not 5. It's 6. Stephen, where are you getting 6 from?
Because you do usually I went with say that 15 that's on top. I went it so I counted how many boxes were and I determined it was 5. So 15 divided by 5 you get 3. So each box is about 3 units.
The boxes are counting by 3s. If that's 15 and it takes 5 boxes to get there, 15 divided by 5 is 3. Each of these is counting by threes. Now be careful also, the x and the y-axis do not have to count by the same numbers. So, looking at the y-axis to tell you x-axis is not necessarily going to help you. They have to be labeled separately, but these ones happen to be counting the same thing. So, left and right I do go first. 6. That is positive because I'm going to the right. I do see 9. Is that also positive? Yes, up is positive. So the center is at 6, 9. Now, radius, again, I should be able to count radii by going either up and down or left and right. Just remember, it goes from center to edge. 6 or is it 2? It's 2 boxes, and 2 boxes is a distance of 6. X minus 6. Close the parentheses, then put the squared. Plus. In parentheses y minus 9. Close parentheses, squared equals 6 squared. Now, some of you might ask, if I recognize the minus and negative turns to a plus, or that the 6 squared is going to turn into 36, can I jump directly to that? And the answer is yes. We got one more on this page.
So they just. Nothing.
Last one on this page is centered at 0, negative 9. Put the laptop away for now, please. Radius of 3 square roots of 5. X minus 0. Yes, that will simplify. No, I'm just not jumping directly to that. Quantity squared plus minus negative 9 in parentheses squared equals but that 3 square roots of 5 needs to be put in parentheses before it gets squared. Because otherwise the squared is only ending up on the square root of 5. Remember, order of operations only puts an exponent on what's directly underneath it. If you need it to go on an entire thing, you need parentheses. And that will make a difference. Because if I go to my calculator and I type in 3 square root 5 squared and 3 square root 5 in parentheses squared, I will get 2 different numbers. I need to square the entire thing. The correct number is 45. And your calculator can do the squaring for you. If you don't want the calculator to do the squaring for you and you want to know how it's done, you square that, you get 9. You square that, you get 5. And what's 9 times 5? The 45.
I still got 15.
Did you put the parentheses in?
Yeah.
Did you close the parentheses before you put the squared on?
I don't know what that means.
If you put the squared here, you got problems. There's your problem. That does bring up a good point. I forgot something, Trevor. Thank you for reminding me. Now, remember on these TIs, when you put a square root, doesn't it open up a set of parentheses?
Yeah.
How many closes do you need to do before you square?
2.
2. So, there you go. Thank you for bringing up that point. I forgot about that. Okay, x minus 0 squared. Can I simplify it? Yes to B. X squared. Y minus a negative 9 squared. Can I simplify that? Y plus 9 in parentheses. Squared. We good so far?
No. My brain hurts. It's only
That's what I got.
10 o'clock.
Yeah. Almost done. Put it away.
And last page, then we got the reviews.
What if You aren't given the radius though.
Oh, no, we have to find
You
it
make it up.
ourselves.
Sometimes you're gonna have to find it.
It's a what if.
If you're given a circle on the coordinate plane in which you don't know what the radius's length is, because sometimes you're going to be given the center and then just a point that's on the circle. We need to find that radius.
Well, we know every circle's big radius.
That is not helping us with the radius. That's angles. Angles and radii are segments versus angles. Don't have the relationship. If you knew the diameter, you would divide it by 2 and you would get the radius. You don't know the diameter. If you are given a circle and a point on the circle, and you want to find this radius, it goes back to how I said the equation was built in the first place. It was built off the definition that this radius is going to be the same regardless of which radius it is. Which means, regardless of which point I give you on the circle, that distance has to be the same, and I can find that distance if I know these coordinate points. Because I can create a right triangle. No! Triangles are fundamental in geometry.
No,
Yes.
we know every single time. Forgot which one.
Now, in order to find the radius, I need to know this length of the triangle, and I need to know this length of the triangle.
Well, if it's a 90 degree, so it's a right triangle, right?
Mm-hmm.
The center is 90.
Where?
Just don't listen to me.
We're going angles again.
How
We don't want
in the
angles.
world-
Okay,
Come on, it's a right triangle.
it is a right triangle.
Angles.
Being a right triangle is important, but stick with me here. I'm going to make this a little bit easier to look at. I am going to make that coordinate point, the coordinate point 6. No, I don't want to make it 7. I purposely don't want to make it 7. I want to make it 10.
Okay.
Okay, let's say this coordinate point here, the center of this particular circle, we know to be the point
That's the key. Consider Ohio.
2, 1.
X.
I'm pulling away from letters for a reason, because y'all know how to work with numbers.
We are. Son.
Now, here's the thing. If that coordinate point is 2, 1 and this coordinate point is 6, 10, we should know what this coordinate point right here is.
7.
Because that coordinate point, would you agree, moves the same distance to the right as that one?
Yeah.
Yes. And the distance to the right is the x value, which means the x value of this coordinate point is the coordinate point 6. Well, that gives me the x. Now, would you agree that this coordinate point also moved up the same distance as that one?
Yeah.
It had to have. Which means its y value is 1.
I knew that.
Okay. Now, I'll make it easier when we get to the actual problems. I'm just trying to explain how we know this.
So we won't ever see this?
No, we probably will.
I did not say that.
Oh my god.
We'll get back to that. Okay. Now, that means I can find this length. Because if the length of this segment is the length between this point and this point, what is the distance between the point 6, 10 and 6, 1? 9. Because the only thing that changed was the y values. Okay? What is the distance between these 2 points? 4, because the only thing that changed was the x values.
Oh my.
And now we have the ability to do Pythagorean theorem.
Once again, retarded.
I didn't actually do it that way. I actually like kind of took what you were saying to bring into like the calculation that we had like for
that's kind of where I'm getting at, Stephen. So, this coordinate point right here, following this, going back to it being letters, that coordinate point is going to be at the coordinate point x, k. Which means this distance is y minus k, and this distance is x minus h. It's the same way you did it when it was numbers. Now that being said, am I ever going to give you ones that have x's and y's and h's and k's and they all stayed letters?
Yeah.
Or are they all going to be numbers? They're all going to be numbers. Okay. So, my point is, you can make a right triangle, and the side lengths of the right triangle will correspond in a way that you can find the radius. So, brass tacks of what you have to do on these problems. Write an equation in standard form for the following circle. Its center is at -4, -2, and the point that is on the circle is at 3, 1. Step 1, plot those two coordinate points, and I recommend you mark which one was the center. -4, -2, what direction am I moving for?
The left.
Back.
Left. 1, 2, 3, 4. What direction am I moving to?
Down.
Down.
Down. 1, 2.
Holy graphs? Oh, that's so weird.
The graph is actually just a tool.
Uh-oh.
We're not actually going to full-on graph them. We're using it as a tool. That's the center. Okay, now I'm going to plot the point 3, 1. What direction am I moving 3?
Right.
1. Up.
What the frick?
All I've done is plot 2 points. Okay, the distance from here to here will be the radius. Can we create a right triangle? With that as the hypotenuse.
I think so.
You go horizontally and vertically to connect those to create a right triangle. What is this side length on this triangle?
1, 2, 3.
3. What is this side length?
1, 2, 3, 4, 5, 6.
Try again.
1, 2, 3, 4, 5, 6.
7.
I don't see no 7.
You have to count boxes. 1 box, 2 box, 3 box, 4 box, 5 box, 6 box, 7 box.
I sure did.
Should be 7. You could also have found those numbers by subtracting these. Big minus little. Or you could just use the triangle. How do you find the radius? Pythagorean theorem. R is the hypotenuse. 3 squared plus 7 squared equals R squared. What's 3 squared? No,
Aw, it's from St. Cloud, Minnesota.
don't care. R squared is 58. Now, traditionally at this point, we would take the square root of it, right? But in the equation, don't I need R squared anyway? So there's no point in taking the square root. The equation says x minus, now be careful, make sure you're using the center,
4.
minus -4 will turn into a plus 4 if you want to jump to that, squared, plus, then it goes y minus -2, and then minus a negative becomes a plus 2, quantity squared equals R squared,
58.
58. I'm sorry if I went over your head with the explanation of where this is coming from, but the actual problems themselves are not too bad. We got one final problem.
It'll be 7.6.
I didn't ask for what the radius was though. I just asked for the equation.
I'm not trying to figure it out.
But you are right. If it asked for what is the length of the radius, you would actually take the square root. Okay. Final problem. How do we start these?
Find your center.
Find the center by
Going on the graph.
going on the graph, plotting the points. I see a -5. What direction am I moving?
Left.
Left. 1, 2, 3, 4, 5.
Up 3.
Up 3. Because it's positive 3. I label that C so I remember that's the center.
Witty. This will be a big one.
Do the same thing with the points.
All the way over down.
1, 2, 3, 4, 5, 6, 7 to the right. And down 2.
Mine's stupid or stupid, so I think I'm all the above. 1, 2, 3, 4, 5.
Connect those 2 points and what do I have? A line that represents the radius. Technically it's a line segment, but I can create a right triangle. I can go down from here. I can go left from here. If you're not 100% sure where they intersect, just make the lines and then all of a sudden your right triangle will pop up. Count the boxes to get the lengths.
12.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can use Pythagorean theorem. 5 squared plus 12 squared equals r squared. That's 25. That's 144. 169. Now I could square root this if I wanted. That would tell me that the radius is 13, but do I need to? No, because in the equation it uses r squared. General structure starts like this. X minus what? Minus a -5? I can change it to +5 right away. Y minus 3
Square.
equals 160. Now, do not forget to put the squareds and the plus sign in between, and be careful. If I give you r, you square it, but if you find r squared, it's already squared. Don't square it again.